Okay, welcome to my first Arduino Uno video. We're going to be making an early project called the SPACESHIP interface, which is included in your Arduino Uno R3 starter guide. So I laid out all the materials prior in this video, and we're going to get to building it. Throughout the process, I'm also going to be explaining how electricity flows from the Arduino or from your power source to the Arduino and then to the breadboard. And I'm going to be explaining some different parts and how they work. It's a very simple project, so it will not take long, probably less than 10 minutes. Then after this, I will also include how to code it, which is, again, very simple since it's an early project. But anyway, let's just get straight into it. So the first thing I'd recommend doing is taking your 220 ohm resistor, which in my case will look like this, and you're going to put it in the breadboard connecting from one of the ground spots. So I'll do that here. It's really important that you make sure that it's connected to the ground. And at the end, when I have all the circuit completed, you can see how the electricity will flow throughout. So now you also have two other 220 ohm resistors required for the project. So you're going to do the same exact thing. So while you're placing these down, it doesn't really matter how far apart they're spaced out. What matters is that they're connected from the ground part, from this ground vertical strip on my left, and they're connected to some space in here. Now I would recommend as well, just to make things easier, that you make them straight so that they connect to a pin that's directly across from them, like I have here. And then you also want to get your 10 kilo ohm resistor, and you want to place it a bit farther apart from the rest, just because this is where our switch will be. And we're again going to put it in one of the ground pins. Okay, now that that's done, we're going to be going on to the main part of this project, which is the LEDs. So in this project, you'll need 2 red LEDs and 1 green LED. The whole purpose of this project is to use code and use the electricity from the Arduino to produce flashing lights in a specific order using a switch. So what you're going to do is you're going to take your light, which by the way has 2 ends. One of the ends is shorter than the other, as you can see there. The shorter end is called the cathode, and the longer end on my right is called the anode. So what you want to do is you want to place the cathode, the shorter end of the LED, directly across from the resistor, and then just put the rest of the pin there so it's all lined up. In fact, you may want to even put it all the way on this side, just because it'll be easier for a switch later on. And you're going to do the same thing for the other LEDs and connect them to their resistors. And now why you might be asking to yourself, why are they in this specific position? And that's because the cathode, the shorter end, we're told in the book that we need to connect it to the ground, and it does that by flowing through the resistor. So now you got everything set up and everything in the right position. What you want to do is you want to get your switch, and you want to place it right across your resistor, just like so. So this way everything's lined up, and the resistor also connects to ground as well. So this is pretty simple so far. Now we're gonna get to the to connecting the jumper wires. So first thing I would do, since it's the smallest wire we're gonna be using, you can use any color, it doesn't really matter at this point, just whatever you have in your starter kit. So you wanna connect from the positive end of this vertical strip, and you wanna make sure that the end point of the wire lines up so that it also connects this part of the switch to the positive side. It doesn't matter how the switch is oriented, as long as it's It can be either this way, or you can flip it around and also, do it that way. All that matters is that one end is connected to the ground and one end is getting power, which is being supplied from this strip here. All right, so now that you have this down, our next step is to connect more jumper wires, the medium-sized ones. Doesn't matter what color they are, just as long as you have them. And you're going to connect the anode part of the LED. So just a pin that's across from that anode side. So the anode is on right here where my finger is, and this wire is placed directly across from it. And we're going to place this wire in the pin labeled 3 on the Arduino. And so you might be wondering, this is how it gets electricity, but why is this one connected to the pin and why is the switch connected to the positive side? Well, we could also put the LED on the positive side, and it'll still get the electricity it needs. But in this case, we have specific commands we want to run on the Arduino when we start coding that make the light bulbs flash on or off directly at the start of the program. And so we need them to be connected to the Arduino. And so you're going to do the same thing with the red LEDs, except for this one in the middle. You're going to be connecting it to pin 4. And this is very important in your coding too, because we're going to have to direct specific pins to do specific actions. And so it's really important that it doesn't need to be, exactly in the same pin. You just need to know which pin it's in and make sure that, you're on page with everything. We're going to be taking another longer wire. I would recommend it's a different color than the ones you used before, just so, there's a variation. You can see which wire is doing which job. We want to connect this wire right in front of this resistor right there. And we're going to take the other end and place it on the pin labeled 2 on the Arduino. So the reason we're putting this wire here is because we need to know whether the switch is on or off, and this wire will send that message to pin 2. So in our coding, we're going to use an if, just a teaser. We're going to be using an if statement that will direct actions of the Arduino based on whether the fact that the switch is on or off. And so that's why this wire is there. So now that everything's set up, we're going to take our, these standard black and red wires, the ones that come in your kit, and we're going to place the red wire from the 5-volt pin, which is a power pin, and we're going to put it on a pin that's connected to this red, the positive side, making sure that the rest of your connections are, not spaced away, but you want to make sure the rest of your connections can receive the electricity. So I would usually recommend putting it at the top, or if you want, you can even put it at the bottom. And with the black wire, we're going to be putting it on the ground pin and connecting it to the negative side. And so usually in electronics, especially Arduino stuff, a red wire always signifies that there's power going from, or power is being supplied to the breadboard. That's why you have a red wire. And a black wire is always a ground wire, so electricity is moving away from the circuit, electricity is moving to the circuit. That's kind of how I think about it. Might not be the exact way, but just think red wire power, black wire ground. All right, so that is our finished circuit. That's what it's going to look like. All right, so now you can add a decal on it if you want. This is a little cardboard piece they also give you in your starter pack. I would also attach some tape to it because it will not fit perfectly. But after you fold it, you can just slide it on if you want. All right, and there you go. It is a bit messy. The cardboard is not the best, but the system will work, and it'll work when we code it. All the wires are connected. All the resistors are placed correctly. And and the main parts of the circuit we can see and interact with. So that's all that matters in this case. Now let's move on to the coding.
Alright, so now we're on the programming part of the Spaceship interface project. And so whenever you start up a new project in this coding interface, you're going to get the void setup and the void loop functions. So I'm going to quickly debrief what these mean. So the setup is something that runs once in your Arduino project. It's kind of self-explanatory. When the Arduino first powers on, you want to set up your pins so they're doing their job correctly. So you can, for example, declare a pin as an output or an input. And the loop, that loop will run continuously after the setup is completed. So after the setup is completed until your program ends, the loop will keep running and running on forever and ever. So in this project, what we're going to do is, here's where we're going to put like the main code of the project. It's where we'll code the lights flashing on and off, depending on whether you flick the switch or not. And then anything before these two, I'll give some space here, anything between those two, you can declare variables. So for this project in particular, we're going to create a variable called switch state. And so the way I'm doing this is I'm going to declare as an int, which means an integer, so any number that's not a decimal, no negatives either. I'm going to call it switch state, give it a good name just like it is in the guidebook, and I'm going to set the variable equal to 0. So we're storing that value 0 into the variable switch state, and that's an integer. And so this is a pretty basic project, so that's all we have to put in the beginning. Next, we're going to go to the setup. Again, this is where our setup code will go. So in this case, we're going to use a function called pin mode. This is one of the most essential. So in pin mode, I'll write one out and then I can explain it. We're going to assign pin 3 as an output. And if you remember, when we were building the Arduino circuit, pin 3 was connected to an LED, and that LED is an output. So that's why you put output there. So the pins connected to the LED, pin 3 will be an output, because the LED, the flashing light is something that comes after the input. The input will be the switch. And we also have pin 4 and 5, which are both outputs because they both are connected to LEDs as well. And you can just copy and paste those. And then lastly, we have, just a quick side note, whenever you're coding, in many programs, but also in Arduino, you always want to end it, you want to end everything with a semicolon besides, the functions here, but you want to end everything with a semicolon. The statements, you want to end with semicolons. But next, we're going to create another pin mode. This time, we're going to do it for pin 2. And instead of making it an output, if you remember when we were building the circuit, pin 2 is actually connected to the switch, so we're going to make that an input. Just like that. And that's pretty much everything you need in your setup. Also, a side note is that you can also add comments in your code. So to add a comment, you just, I'll do it at the bottom here. You just put 2 forward slashes and then write whatever you want. It won't affect the code in any way. The computer will just skip past it. It just, you can put your pseudocode here. Pseudocode is like how you mentally process what's going on in your code. So, for example, you could write something like pin 3 connected to LED, which is an output. So whenever you don't understand something, you want to remember something, especially for our if statement later on, you can add pseudocode. But anyway, next we're going to go to the void loop. And in this void loop, we're going to add a new function called digital read. And so digital read is a cool function because it allows you to check the voltage level of a digital input. The only thing that digital read expects an argument. An argument is basically information that you need to tell the function so that the function can do its job correctly. And in this case, all digital read needs to know is what pin to check for. And so what we're going to do is we're going to set our variable switch state, which is previously set to 0 up at the top, and we're going to set that to equal digital read 2. So basically, first off, we're going to apply the digital read function to pin 2, which is connected to the switch. So I'll actually write those down here. And whatever value we get off of that, we're going to store it in the variable switch state. And it's important that we check the voltage level of the pin, because that'll directly relate to the switch, and then we can create if statements for what happens when you press the switch or not. And so now in the same loop, we're going to add something called an if statement. An if statement in programming compares two things and determines if those things are true or false, and then you can get an expected action based on whether it's true or false. And then when you're comparing something, you also want to make sure that you add two equal signs. So I'll show you right now. So we could put if switch state equals equals. Again, that's the double equal signs. If you put only one equal sign, it's going to think that you're declaring something or you're setting a value to something, which is not what we're doing. We're comparing it if they're equal. So if the switch state is low, and what I mean by low is if there's a voltage in it. So if there's no voltage in the switch, it'll be represented as low. And if there is a voltage, it'll be represented as high. High and low actually have values. So the high value has a value of 1 and low has 0. So let's take our declaration prior. So if we read pin 2 and we found that it had no voltage, that means that switch state is equal to 0. So if switch state is equal to low, which will be the case in that specific example, it'll execute a specific action. And here's the action I want to tell it to do. And by the way, you want to add your curly parentheses at the beginning and end of all if statements. So here's our action. Alright, so here we go. We have our 3 lines written out for what happens if the switch state is low, or if the switch doesn't read any voltage. So if that happens, we're going to execute these 3 commands. Now, the digital write command is something I just introduced. It's a command that allows you to send 5 volts or 0 volts to the output pin. It takes 2 arguments, and those 2 being what pin to control and what value to set to the pin. So in this case, if the switch has no voltage, meaning you did not press it at all, then we're going to set pin 3 to high, pin 4 to low, and pin 5 to low. So what that's doing is it's going to add 5 volts to pin 3, no volts to pin 4, and no volts to pin 5. So if you remember, pin 3 I believe was our green LED, so it's going to flash that on. So it's going to turn on the green LED, and it's going to turn off the red LEDs. And then again, this is if there is no voltage in the switch, so it's not pressed. So that's what will happen, and that's the end of our if statement. Now we also want to plan out for different things that could occur during the execution of our program. And so that's why we have this else. The else statement will come right after the if statement. So if what I wrote in the if statement is not true, so if the switch state is high, then we're going to command something else to happen. So basically the first part of this else statement, we're going to have more on the else. But the first part is that when the switch state is not low, so anything other than that, which in this case it'll only be high, we're going to turn off the green LED, turn off one of the red LEDs, and then turn on the last one. That's why we have high here and then low for the rest. Here's what comes after.